Saxon's Calculus, Lesson 29, is about translations of functions and then rational functions for the first time they get discussed. So we already know a little bit about this. If we have a normal graph that's starting at 0, 0, and doing a curve, and then I shift it up to here to start, that's a translation. And if I'm shifting it going up or down, I'm attaching that shift number to the y value. Or if I need to keep that in an equation, like if I was up 2 and I put the +2 here, I would then be moving it over into the formula on the other side, which would say minus. If I'm shifting it forward to start, that's attaching it with the x, of course. And so that's going to be in a parenthesis, and we're going to change the sign when we write it. Technically, this would have been attached in a parenthesis, and I would have changed the sign. I would have said -2 here, and then it would have been +2 on the other side. Neither here nor there. Example 1 says, graph the function of y equals the absolute value of x. Now, you should recall that an absolute value graphs a v. So that helps you when you are picking values 0, 1, and -1 to see what's happening. So the absolute value of 0, 0, absolute value of 1, 1, absolute value of -1 is also 1 because the absolute value cannot spit out anything other than a positive. So dot at 0, 0, dot at 1, 1, -1 graphs the same 1. And then because I know it's a v and not curved, I just do my straight lines. Now, graph that function. Then change the equation to shift the graph 3 units to the left. So now the start is going to go 1, 2, 3 units to the left and 2 units down. So now the start of that v has moved to here. And then I know that it's still like 1 over 1 up. So I could do the same thing, 1 over 1 up, and mirror image to the other side. Okay, and then draw my V. Then change the equation to shift the graph 3 units to the left and 2 units down. Then graph the new function. Okay, we did that. It didn't ask me to write the new equation, but if it had my y, which was moving me 2 units down, if I attached it over here, would say +2 equals the absolute value of x. And then when I attach the shift of 3 to the left, I'm writing that as +3, ending the absolute value. And then this can't stay over here with the y, so it has to go to -2. So the other way to think about that is, because this is acting as a parenthesis, you're going to change the sign with the x one, but you're just going to fill in on this side exactly what the y was doing, which was dropping 2. Now, example 2. Graph the function of y equals 1/2 x squared. My x squared and a plane y tells me it's a parabola. I might not have needed to do my points because I know it's a parabola. The center, I have no other numbers, so the center is going to be at 0, 0. And I need to find another point. Usually 0 is the easiest one to plug in. So in this case, I'll choose 1. I just usually don't do a chart with it. 1 squared is 1. 1 times 1/2 is 1/2. So we're going to graph 1/2, and then I know that on the other side it's a mirror image, and so here's my parabola, so I don't usually do the XY chart. And then it says change the equation to shift the curve 3 units to the right. So the center is going to go 1, 2, 3 to the right and 2 up. So here's the new start, and then of course that was 1.5 up, so 1 backwards and 1/2 up, mirror imaged, and there's the new parabola graphed. And then graph the new function. Okay, so again, it didn't ask for the equation, but it's going to be y equals 1/2 and then x, and it said to shift the x forward 3, so we're going to fill in -3 with the squared. And then how many to the, on the y value, it said up 2, so we just fill in +2, and we've got it. Example 3. Graph the function y equals 1/2 an x. Now that's not a parabola, that's a line, because the y is plane, the x is plane. So I'm going to treat this as y equals mx plus b. So the b is not there, so it's crossing the y-axis at 0. And give myself a couple of spots here. And my slope is rise over run, so I'm rising 1, running 2, or backwards down 1, backwards 2. So here's my original line. Now, where did it want me to shift? Change the equation to shift the graph 2 units to the left, 2 to the left, and 1 unit down. Oh, well, that puts me at the start right here. So that's on part of this line. And my slope is still up 1 over 2, so shifting that did not change it. So technically, the equation of the new line, which is the same as the original one, would be y equals x, and then it said to go 2 left, so we're going to go plus 2, and then it shifted 1 down, so we're going to write minus 1 with that one. Example 4. Given that y equals the absolute value of 4 sine of x, and then change it. Okay, so my sine, no front number, and then although technically that 4 is changing my height. So, but my center line is still 0. My height has changed to 4, and negative 4 for the low point. Sine means start in the middle. It's positive, going up first. And I know I need 4 sections, but the absolute value tells me that when I get to the negatives, I can't go there. I'm bumped back to the positives, so I'm humping this. 1 loop, 2 loops. So there's one set of it. Now it does continue on and on and on. Now it says change it so that the graph is shifted 2 down, but pi over 2 units to the right. So if originally I was picturing this in degrees, but in radians, this would be 2 pi. This would be pi, so this would be pi over 2. It's the standard from your 4-quadrant grids. So pi over 4 is only a portion of that. So now it's starting here, and it's still going up 1, 2, 3, 4. I had trouble with that. So this is my new high point for the next, and it's going to be a little past that. So here, something, it should curve a little before that. Okay, it should be doing something along that line. And then if you want to write the equation out, it's y equals the absolute value of 4 sine of x, and because we went forward pi over 2, you're going to write minus pi over 2. And that ends the absolute value, and then we dropped it 2, so minus 2 at the tail end of that. Okay, part B, rational functions, for the first time we talk about them. And they're titling it, even though they're saying graph this, which looks like a continuation of that. So it's graphing 1 over x. And their title said rational. Okay, so rational is, remember, anything that you're graphing that's not the weird stuff, pi, e. So it's got to end or repeat in its decimals. So the reason they're doing this one in a different category is because these are going to be creating asymptotes. So when I go to do my graph, the very first thing I realize is that if I can't put a 0 in the denominator, so this is acting as an asymptote line. I can't touch it or cross it. It's going to skew my picture. So if I had done 1 and negative 1, 2, let's say, so 1 over 1 is 1, 1 over negative 1 is negative 1, 1 over 2 is a half. So I'm graphing something like 1, 1, negative 1, negative 1. And that's one dot on either side of my asymptote. 2 graphed a fraction, and so I know that this is going to skew as I try to get closer, and this is going to skew to the x-axis. And then once I have the 1, I know I'm doing the same thing. I'm skewing down to this asymptote, and I'm still climbing here, but I'm going to be bounded by the same x-axis. So there is the graph of y equals 1 over x. Now, example 6 wants you to do a shift here. So y equals 1 over x minus 3 plus 2. So they want you to see that it's shifting from where it just was on that one, so that the asymptote line is no longer this axis. It's going to be, see, positive 3 and positive 2. So in my vertical asymptote, it's going to be here at 3. And what was my x1 that was an asymptote has now shifted to the 2. And then I'm going to have the curves bounded by both of those. So I could be really precise and actually plug in the numbers and get those actual, like a dot on either side, but you can also just get it this close. Example 7. Y equals negative 1 over x. So now what happens when we make it negative? So I'm back to the same boundaries of the two axes that we had from before, but the negative shifts me to here and here. Because before we were in this quadrant, now we're down into the negatives and it's opposite. B does the same. Y equals 1 over 3 minus x. Now, that's a negative x like so, and the 3 is adding 3, so technically I'm going backwards 3. Wait a minute, positive 3, negative. It's written the other way, x. Oh, okay. When I have the negative, it's changing both of the signs when I'm trying to fix it. So it's going to do the same thing as this one, except it's going to go to the 3 and should still be the 0. Yes, the 0 for this one. So my negatives were graphing down here. So now here's that graph and then that graph, because it's still, there was no change to the y, so I'm still bounded by that axis. Now in C, it says y equals 1 over x squared. Okay, so I can't have 0 in the denominator. This is an asymptote line. If I plug in 1 over 1 squared is still 1. When I plug in negative 1, I still get 1. When I plug in 2, I get like a 4th, so that's tiny. Same thing is happening over here. I'm getting it tight, and so I know I'm getting a graph like so. Not sure why they're showing me a picture of it underneath. Hang on. Yeah, the only reason they showed that was because they made a statement that says with an x squared, it looks like a volcano. If it had been a negative x squared, it would look like a downward volcano. I knew that wasn't part of the actual graph they'd asked me to do.